Going to look at how to both interpret and draw graphs. And these graphs will take a variety of forms. For example, it could look like the one that you can see in this picture here, or it could be something that involves line segments. We're going to look at both of these types of graphs and how to interpret and create them in this reference guide. All right, so some of the material in this reference guide is going to seem very, very straightforward. The first question that we're going to do will probably seem quite straightforward, but it's important to pay attention to detail when you're doing these problems so that you don't miss anything that may seem obvious. Now let's take a look at the sample problems right now. So there are no definitions for this reference guide. It's just a matter of either A, being presented with a graph that you have to pick some information off of, or B, being given information and in turn creating a graph, which is what we're going to do in problems 2 and 3. For the first problem, you'll notice that we're talking about the cost and the mass of various bags of popcorn. So there's 5 bags of popcorn that are plotted on this graph. They are labeled with the letters A through E. So each letter represents a different bag of popcorn, and each bag has both a cost and a mass. And you'll notice that the labels on each axis will tell you what pertains to what. So as you go up, as you get higher up on the graph, the cost is increasing, because you can see your labels on the y-axis are 2, 4, and 6, and the higher you go up, the bigger the number gets. Likewise with your x-axis, as you go across to the right, the mass is increasing. We have 400, 800, 1200, 1600, and 2000. Those numbers increase the further right you go. So dots that are further to the right are going to have a higher mass. And when you're given questions that pertain to a graph like the one seen in question number 1, it's just a matter of being able to pay attention to which axis you're looking at and compare the dots that are on the graph. So for example, question A, which bag is the most expensive and how much does it cost? Well, again, we can see that as we go up the y-axis, our cost gets higher and higher and higher. So we are looking for the point of the 5 that is the furthest up. And we can see that point C is the furthest up. That means it's going to cost the most. And when we look at point C, we can go across to the label on the y-axis, and 7 isn't written there, but it would be next in line. So bag C would cost $7. And that's all there is to questions like that. You're just essentially taking the graph and picking some information off of it. B, which bag has the least mass? So which weighs the least? So now we're looking on the x-axis, so we're looking for the one that's the furthest to the left. Well, the bag that would weigh the least would be bag B. And with bag B, we can see that it lies somewhere between 400 and 600, and it's kind of right in the middle. So we would state that bag B weighs approximately, or about, or as you can see here, appears to be 500 grams. All right, and anytime that you're doing some estimating, just pick a nice round number, but make sure that it's accurate. Part C, which bags have the same mass, and what is this mass? Well, in this case, we're looking back again at the x-axis, because that's what mass is represented on. And we want the 2 that line up, the 2 that have one on top of the other. And in this case, it's going to be bags D and E. You can see that they are on the same point on the x-axis. They are both at 1,800 grams. They are right here. All right, so they both have the same mass. Bag C has a different mass from A, B, D, and E, and so on. All the other bags have different masses. So now we go to part D. Which bags cost the same and what does this cost? So now it's the same idea, except we're looking at our y-axis because that represents cost. Well, these would be the 2 bags that would be on the same row. And if we look at this row right here, we can see that there are 2 bags that are on that row. They are at $4. So there's 2 bags that line up, parallel with the arrow I just drew. They would both have the same cost. Bag B doesn't. It's on its own row, as are D and C. So in this case, the 2 bags with the same cost are A and E, and that cost is $4. And our final one, which of bags C or D has the better value for the money? Well, in this case, there are certain things that are implied. It is implied when we talk better value for the money that we're talking about more popcorn for the price paid. There are obviously certain circumstances that could make it justifiable to pay more money and get less popcorn. But we're not taking into account any of those because there's nothing in the question to indicate that. So all we're talking about with part E is if we're looking at bags C and D, which gives us more popcorn for the less money or for paying less money. So we compare C and D. Well, C is here, D is here, and you can see very clearly that with bag D you get more popcorn. With bag D, you're getting 1,800 grams of popcorn at a cost of about $5.50. Whereas with bag C, you're getting 1,600 grams of popcorn at a cost of about $7, or at a cost of $7. So we can see quite clearly that with bag D, we get more popcorn, we get 200 grams more, and it costs $1.50 less. So ignoring all possible external factors that may make it more desirable to buy less popcorn, such as name brand or maybe a type of flavoring or something like that, just taking the question at face value, which is better value for the money, we would then conclude that bag D is better value for the money because you get more popcorn and you pay $1.50 less. Alright? And that's all there is to questions like number 1. You're going to be given a graph, it's going to have some number of points on it. Your job is going to be to just answer some questions based on the points that are given. Alright, so question 2 is a different style of question. Question 2, you're given a graph again, just as you were before, but instead of being asked to pick little bits of information off of it, you're being asked to describe each segment. So here we have a segment from 0 to A, from A to B, B to C, C to D, and D to E. So there's 5 segments here that we're going to have to explain. When you explain this, and you'll see it in the example that's done, or the first segment, you're going to include 3 things if you can. You're going to include a distance, you're going to include a direction, and sometimes that direction will be north, east, south, or west, or sometimes it will be toward or away from a particular destination. And the final thing you're going to include is a time. And you may not be able to include all of those things for every graph or for every segment of every graph, but when you can, those are the 3 things you want to incorporate into your description. So if we look at the description of 0 to A, it says in this segment, the person travels about 65 kilometers, there's our distance, from Winnipeg, there's our direction, they're going away from Winnipeg. In approximately 1 hour, there's our time. So we want to hit those 3 points if we can. And now, we're going to go through and we're going to explain the rest of the segments. Well, A to B is just a brief little segment, and it's a horizontal line. And if you're looking at a distance versus time graph, a horizontal line means that the person is stopped. They are not moving because they're not covering any distance. So we know that the person is stopped. We need to then figure out for how long. Well, they're stopped kind of right in between 1 and 1.5. So they're stopped between 1 hour and 1 hour and a half, and it looks kind of to be right in the middle. So we would say the person stopped for about 15 minutes. And now you'll notice with this case, with this example, they don't include a direction. They don't have to include a direction. They've stopped. There is no direction. They're not moving. So that's A to B. So they've stopped for 15 minutes. So we're an hour and 15 minutes into the journey at this point. Now we're going to go from B to C. Well, from B to C, they're driving, again, you can tell because their distance is increasing. If they've already covered 65 kilometers, and they're going to end up at about 130, we would say the car drove about 65 kilometers. And again, we can say away from Winnipeg, there's our direction. In about 45 minutes. And you can see with that description that we've hit all three things we need to include. We've hit a distance, we've hit a direction, and we've hit a time. So we have everything that we need there. So now we go from C to D and we're faced with another horizontal line. And that means the same thing. The distance isn't changing. They are stopped. We know that they're in Winkler because that's as far away from Winnipeg as they're going to get. So we would just say the car stopped in Winkler and they start at 2 and they end at 4, so they're there for 2 hours. So the car stops in Winkler. So again, we're as specific as we can be. We know where they are, so we'll include that for 2 hours. And then our final segment, D to E. Well, they're leaving Winkler, now they're heading back to Winnipeg. So everything moving upwards, all lines moving up, are heading away from Winnipeg. So in turn, all lines moving down would be heading back toward Winnipeg. So they start at 4 and they end at 6. So segment D to E, the car drives 130 kilometers to Winnipeg in 2 hours. And again, we can see everything we need. We have a distance there, as I just underlined. We have a direction there, as I just underlined. And we have a time there, as I just underlined. So again, when you can, you want to hit those 3 big points. You want to have a distance, you want to have a direction, and you want to have a time. And when you're describing line segments, this is a senior high course, so be as thorough as you can. Incorporate those 3 details, make sure that your answer, if somebody was just wandering in and happened to see your description, but not the graph, they could have an idea of what the graph might look like. Right? And then the final question really puts it all together. Here we're going to do both. We're going to create a graph, and then we're going to describe the line segments in it. So it's a bit of a longer question. So Samuel went on a bicycle ride. He accelerated quickly until reaching a speed of 20 kilometers an hour. Then he cycled at 30 minutes at approximately 20 kilometers an hour. So he goes at a constant speed at that point. He arrives at the bottom of a hill, and as tends to happen on a bike, when you meet a hill, your speed decreases, and it decreases dramatically, so it must have been a steep hill, to 5 kilometers an hour for 10 minutes as he's going up it. When he gets to the top, he is naturally tired from just cycling up a hill, so he stops to rest for 10 minutes. We are sketching a graph as a function of speed versus time. So we're going to label each section of the graph and explain what it represents. So function, speed as a function of time, means that speed will be on our y-axis. Try this again. So speed will be on our y-axis. So time will be on our x. Can't write speed on our y for some reason. So time will be in minutes. Let's try it like this. There we go. Speed is in kilometers an hour. So you need to ensure that you label each of your axes. Make sure that you put your units on so that you don't have to write your units on every number value that you include as well. So we have his speed, we have his time. Now let's label in, or let's put in our numbers. Well, the highest his speed is going to reach is 20 kilometers an hour. So that means that we have enough room to play with that we can be quite thorough with our axes. So I'm going to go up by 2s. So 4, 8, 12, 16, and 20. So there is our labels. We're going up by 2. So this would be 2, 6, and so on. Now with our time, he is going to be going for 30 minutes. then 2 sections of 10 minutes. So we have to cover just a little bit more than 50 because there's a couple of times he accelerates and slows down. So with that, I'm going to go across by fives. So 5, 15, 25, 35, 45, 55. So there we have our labels, and then the last thing we put in on a graph is we put a title. So this is Samuel's bike ride. And then I'm going to go even a little bit more specific. I need to have this detail, but I'm going to put it in. Speed versus time. Now we're going to go through and we're going to look at each segment, and we're going to fill in what we know. Well, we know that he accelerates quickly until reaching a speed of 20 kilometers an hour. Well, he's not just going to start at 20 kilometers an hour. He's supposed to start at 0. So that quickly, it may seem just like a bit of an arbitrary word, but it's important because it means that some amount of time has taken place. Not much, not full minutes or anything like that, but some amount of time has taken place. So we put a dot just off the y-axis. We're going to connect that dot with a line. So it's taken a little bit of time. That's just off the y-axis. And then he's going to cycle 30 minutes at 20 kilometers an hour. So we go just a little past 30, and we put a dot. And then we continue drawing our lines. Should be straight, but having trouble drawing horizontal lines right now. And then he's going to arrive at the bottom of a hill, and his speed is going to decrease to 5. So we go to where approximately 5 would be. We put our dot. And we connect it. So again, it's not a perfectly vertical line because that is taking him some time. There's a bit of an angle there. Then he drives at approximately 5 kilometers an hour for 10 minutes. So he's just past 30 minutes now. So we'd be just past 40 minutes when we put our dot in. And then he's going to stop at the top of the hill for 10 minutes. So he is just past 30 there, 40 there, so he's going to be about there when all is said and done. Alright, so it's a little harder to draw that with the pen than I had thought, but your graph should mostly look like this, and you can see each of your segments and what they would represent. And now we're going to go through and we're going to indicate what each segment represents. So I'm going to label it, so we have some starting point, and we're going to go through, and I believe that there's 7 segments there. So the first segment is 0 to A. So 0 to A, you have Samuel accelerating quickly until reaching a speed of 20 kilometers an hour. But we don't have a direction here. We just have a speed and a time, and quickly, even though it's not specific, is a time. So we would say Sam accelerates quickly from 0 kilometers an hour to 20 kilometers an hour. There's our first line segment, 0 to A. So A to B, he is traveling at a constant speed. So he's going at 20 kilometers an hour for 30 minutes. So Sam travels at 20 kilometers an hour for 30 minutes. From B to C, we have him slowing down quickly. all the way from 20 down to 5. So Sam slows rapidly, we use a different word, quickly, from 20 kilometers an hour to 5 kilometers an hour. Now from C to D. He's going at 5 kilometers an hour for 10 minutes. Sam travels again. We're putting in all the detail that we know. We're almost done. So then D to E, that's a segment that most people would forget in this. It still has to be a segment if he's slowing down and he's going from 5 to 0. So Sam quickly slows from 5 kilometers an hour to 0 kilometers an hour. And then E to F, our final segment, is when he rests for 10 minutes. Okay? So aside from the creation of the graph, which was a little bit more tricky to do with this pen than I had anticipated, in terms of drawing vertical lines and things like that, but otherwise you get what the graph will look like anyways. That's all there is to this. You just carefully go through, you look at each little bit of information, and you represent it. Make sure you clearly label your axes, make sure you give it a nice title, and make sure you're thorough when you are detailing what's happening in a graph. All right, and that's all that there is to that reference guide.